I really believe in the philosophy of giving value to the world. I don't know where it's going to lead you, but if you just put yourself out there, continually producing value, things will just come upon you. Learn these technologies. I'd learned how to build a blockchain on the Ethereum testnet. I'd go to a high school and I would give a guest talk, and I would convert the whole classroom into a blockchain, and we would actually execute a whole consensus. And the students were actually doing the transactions and being the blockchain, so they had to solve a mathematical equation.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry, and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today we have John Herke, a developer and technical evangelist at TigerGraph and also founder of Futurist Academy. TigerGraph is a scalable graph database for the enterprise, and with their proven technology, it helps to connect data silos for deeper, wider, and operational analytics at scale. Futurist Academy is working to reshape the future. They leverage the latest technology and innovative ideas to mold a future of self-empowerment. With their platform, educators will be able to host their creative teaching solutions, styles, and agendas. In return, students will be able to pick which courses best fit their learning styles or need. Besides all of this, which was a mouthful, John's got a very interesting background and career. He's worked for everything from Fortune 100 to startups. And most importantly, John, I don't think I've ever told you this, but I appreciate and thank you for your service to our country as a member of the Army National Guard. So we're here today to talk about AI. And I gave a little bit of a background, I guess, of where you're currently at. But, if you could maybe share with the audience a little bit about, what you've been doing here in your career.
Career. It's an interesting word. You grow up and you think that you're going to be something, and then, life just comes at you, and you're always not knowing what's going to be in the future. And I tend to live in the moment, and I don't know where it's going to go, but I'm excited to be here. It led me to you. It led me to all of the great peers I have in our home state here in Minneapolis. So a little bit about me. My background in the military was a computer networking engineer. What that meant is that I would go out in the middle of nowhere, shoot up to a satellite, grab an uplink, and deploy a network. So just imagine a barren field of nothing, and then you bring all these big boxes in, and it has the networking equipment, routers, switches. And you bring big trailers that have these dishes that shoot up to the satellite, and then you got to connect everything, program everything. So that's what I did in the military.
Were you always into technology, kind of a geek growing up at all?
I would say so. I mean, I was one of those kids that, built the computers and websites back in the day, back in MySpace. I date myself to the younger folks. For the older folks, they're like, yeah, you're still young.
And I do mean geek in the nicest of ways, actually. It's a loving term. I call myself that all the time.
Yeah, peer technologists love future thoughts and relating them back into reality. I did have a startup. We can talk about that later.
Cool. So after the military, you're out here doing networking stuff, crazy stuff in the middle of nowhere. What kind of led you then to the next phase of your career?
So I'm a networking engineer. I had a secret security clearance by the Department of Defense, all my certifications, and then I applied for an internship at UHG. And they're like, man, this guy's like a super intern. He's got 6 years of experience networking. He's got all of his certifications, and they let me do a lot of cool stuff there. Working for a large company and doing networking is a little bit different than being out in the middle of a field. It got a little bit repetitive. You can't go wild, wild west on your networking equipment back. I got a little stale. I, at that point, decided to explore different options. And just by happenstance, I got an email that was somebody looking for somebody in the group called The Garage. And The Garage was a healthcare startup incubator. And so I said, why not? I love entrepreneurship. I love technology. I love being creative and building things. So applied there and got the position as sort of an entrepreneur in residence. So building healthcare startups. So it's like a 360 from being a very technical guy to building healthcare startups. But when you're building a startup, there's a lot of system architecture, a lot of thought process that goes into that, and deep thinking and execution. So it wasn't totally something out of the blue, but I did that for a couple of years, 2 different startups. One was really successful, one was not so successful, but got to learn a lot. And it wasn't just me. I was actually working with other founders and stuff there. And then in August 2016, we spun off and created this group. We focused on emerging technologies called the Advanced Technology Collaborative. The startup incubator was very business model focused. So what that means is if you were to create Uber, the technology existed, people existed, the cars existed, the phones existed, everything existed. It was just a way to rethink about how business would operate. And so that we did a methodology called running lean. That was very business model focused. But the thing that we kept running up upon was that there would be a lot of these emerging techs coming out, like AI and blockchain things and NLP and computers, all these crazy cool things. And we're like, what are we doing to address this space? So back in 2016, we created this division that was explicitly looking at emerging technologies and looking and understanding them and how they could fit in the healthcare space. So a good example that everyone probably could relate to is if the internet came out, what is it? Why do we care? Is it a fad? Is it going to be here next year?
Sure.
Can we make money off it? There's so many questions, oh yeah, that's not important. The internet, like who's going to use that? There's so many questions and unknown variables when new technologies come out and people just don't understand them. So what we wanted to do was hire people that truly understood these technologies and that we had the people that truly understood the business and then put these people together and we built cool things.
Nice.
So that was my time at UHG, going to entrepreneurship, building out this department, and then going back into technology. So I really pushed down on graph technology. So we worked on blockchain, AI, graph databases, quantum computing. These are just general emerging technologies. I emphasized my passion and networking into graph. Did that for a few years, and then I got picked up by the company TigerGraph. They saw what I was doing in the community, doing things with Futures Academy.
Yeah, well, let's talk about Futures Academy. So
Yeah,
that's all really good. I mean, you've built up this deep knowledge, obviously working with people on all these really cool emerging technologies. One of the best things I think about your story, John, is just I really sense you love to get back, right? You really love working in the community. So this would be a good time, I think, just to maybe talk a little bit about what Futures Academy is.
So the Futures Academy really spun up on the knowledge I was accumulating, the connections I was accumulating, the knowledge I was accumulating, and as you said, giving back. I really believe in the philosophy of just producing value to the world, giving value to the world. I don't know where it's going to lead you, but if you just put yourself out there, continually producing value, things will just come upon you as such. Meeting you guys, meeting TigerGraph and everything else. So with that being said, I would learn these technologies. I'd learn how to build a blockchain on Ethereum testnet. I'd go to a high school and I would give a guest talk and I would convert the whole classroom into a blockchain and we would actually execute a whole consensus. And the students were actually doing the transactions and being the blockchain. So they had to solve a mathematical equation.
Oh, nice.
And then, so we walked through sort of the history of why electronic currency exists, why there's this thing called value exchange, the whole reason there's money. And then we walked through blockchain. We actually launched our own coin in 5 minutes on the Ethereum testnet. So everyone got the experience of understanding that technology. And this is a high school class. So you have to really articulate and understand the technology and then be able to bring that into a classroom. So I did that also along with other technologies, including AI. So computer vision, since you guys talked to Dan McCreary, the AI Racing League, and you have 11-year-olds building self-driving cars. I think it's just really cool to say that.
That's awesome. Yeah.
And, capturing data, creating models, and then taking those models, putting them back on the car and letting them drive around. But the whole point is taking these emerging technologies. I really loved going to different meetups, different schools, and I got the question, how can we be part of this? How can we be part of this? All the time. How can we be part of this? So then we decided to create an organization around it called Futures Academy, our primary directive is really looking at these emergent technologies and bringing them into the education space. So, addressing education gaps, because the technology themselves are so exponential. There's no way that a teacher can comprehend that knowledge and share it back to the students, right? They went to school like 10, 15 years ago. There's no way that they have that much knowledge in these spaces. So you have to literally be real-time education and plugging that back in. And that's what we're trying to do, is provide that mentorship, the ability for these students to get real world experience, work on real projects, mentor and be with people.
That's awesome. That's awesome. Yeah. I mean, the next generation is always really fascinating to me, with regards to not only the technology, but also the people that are going to be working in it.
Mhm.
Right. And so the more you can bring them up to speed and into the fold sooner, the better. It just improves our entire society. So I commend you for the work that you're doing there. And it sounds very interesting. I guess I'm curious, as you've got a lot of different things going on. What's a typical day in the life for you?
I so thoroughly enjoy what I do. I don't realize where work begins and work ends. I just love learning. I love sharing. I love teaching. I love mentoring. And it all just sort of overlaps. So, I wake up, have coffee, and do that, maybe do some workout, check the emails kind of stuff. I would say most of it is really working with community members, working with students, sharing my knowledge, sharing what I know, and getting people excited. I think there's a disconnect, and it's not that people are not smart, it's just they're not engaged. They're not challenged. I was never, I don't think, challenged enough in school, to be honest. I was so bored of the regular curriculum. It's just we need to get out of the tests,
Yeah.
to be honest.
Yeah.
Get people passionate, like get them a reason to be passionate, get them like understanding why they're doing this algorithm, why they're learning cosine similarity, when you could be like, hey, let's build our own social network. Oh, by the way, we're going to implement cosine similarity.
Sure.
That introduces them how to like find similar people. Maybe these people go to this group and you want to go to that group, so we're doing a cosine similarity to determine what group you want to go to. So it's giving some context to that specific learning.
Absolutely. Absolutely. Yeah, it really drives the reason as to why you're doing it, not so much how you do it.
Yeah.
And the technology will come in, but as more and more people know. And so let's dive in a little bit around AI. I mean, the whole sort of purpose in some ways, or a lot of our discussions here, is really applied AI, which you've definitely touched on here in a
Mm-hmm.
number of different ways as you've been out in the community, as you've been working day to day with Tigergraph and stuff like that. How do you define AI? I guess maybe let's start with a little definition. How would you define it for somebody? It's such a broad topic, it touches everything, but I'm always curious to find out, if you were in an elevator, somebody that didn't know anything about it, what's the elevator pitch on like what what's it all about?
Yeah, artificial intelligence. I would say artificial intelligence is anything that a computer system can articulate and provide you its derived insights. So it is trying to come up with something that it thinks, whether it's by you feeding it data or it trying to learn that data or whatever it is. It's trying to articulate its own thought, or it's trying to derive an output, right? So I think that's as broad as you can get it, because there's so many things under AI, like NLP and computer vision. So it's like,
Yeah.
yeah, I would say anything that's sort of like trying to articulate and come out with an output, is really what it is.
Yeah, for sure. I totally get it. I totally get it. That's big picture. That's sort of this overarching thing which can be applied to a number of different areas. Curious to see, as you're working today, day to day, you're in there trying to solve problems. Have you seen anything interesting that you can share? I guess I know some of the clients, maybe stuff you guys work with or whatever, are proprietary in some ways, but like how you are seeing AI being applied. It could be graph related,
Mhm.
or it couldn't be. It could be like, hey, I read about this interesting article or this new way that artificial intelligence is being used, and I found it interesting.
Yeah, there's a number of paths we can go. Let's start with the easiest one for graph, and then I'll go to some other ones that I find fascinating. For graph, what's interesting from a perspective of a data scientist, or I don't know if there's a technical term for a AI data scientist, but what I've been finding with those that use graph, they're just sort of in shock that they can derive this information in such a fast manner. And what I mean by that is typically the workflow of a data science engineer is that they're trying to derive information. So they're working on creating all these big joins of big data sets, and then they like run them overnight, and then like, oh shoot, I got something wrong, I got to run that again. And then they're driving all these different features that they're going to eventually feed into their model, right? And
Right.
then they get on to graph for their first time, and for graph, for those aren't familiar, it's basically no joins, it's everything sort of pre-joined. And so you're given sort of a map of the data, and the map is telling you where all the data resides. And then what happens is that when you're writing your query, you're just accessing places where your data resides.
Mm.
So essentially, you don't have to do the joins, you're just accessing the data. So think of like Google Maps on top of your data. And so yeah, they'll run their feature set extraction on the graph database, and they're just like, wow, I could just derive the feature. Like I didn't have to create a derived feature set. I could like literally just access the data and just get back that data for that specific thing. It's all pre-joined, so I didn't have to sit there and wait forever for it to go through and every single row and join things up. I just accessed the data that I needed.
So once the data is accessed, which is phenomenal, and I talked a little bit with Dan, we touched a lot on graph and sort of the speed of it and typical use cases for it. It's not can't be used everywhere all the time. It's not like a silver bullet. You always want to put
Yeah.
data in graph. But I guess I'm curious to know, once people see this and they're like, okay, this is awesome. How do you then train models back? I mean, how do you bring in sort of the learning into the graph database, or is that something kind of different?
Yeah, so you can take your derived features and then put them as attributes in your graph as well. Okay, so if this is AI everything, NLP would technically be
Mm-hmm.
AI-ish doing it. Yeah, so I mean it's falling under AI. So for example, let's say we just had this. One of the students from Futures Academy, they took SciSpacey, an NLP model that's trained on Allen AI Institute biomedical literature, and they took the 60,000 abstracts for the COVID-19, and what they did was they ran it through the SciSpacey model to do entity extraction, and after they did the entity extraction, they took the extracted metadata and then semantically linked it in the graph. Then that allows you to build sort of a knowledge graph, and so then on top of it, you can put basically like Google search. Now you can say, give me all the papers with cancer, right? Bam. Because it's semantically linked, and then you have entities and then you have classes. You can go from the class and then go down. You can go narrow. Or the other thing is take all the papers, run a cosine similarity or a Jaccard algorithm, and then derive the most similar papers to the one that I wanted to. Let's say I found a really interesting cancer paper, and I wanted to be able to find other cancer papers that are most similar to this one. Bam. There you go. So there's a lot of things that you could do to like enrich the data that itself using AI, and then use that to either enhance the graph itself, creating more semantically linked connections between the data elements. And then you can also do where you do feature set extraction, and then you run it through your model and come back, and it comes back with maybe like a pre-weighted score that can be used for another thing.
Mm-hmm.
So you can do it that way. I'm sure the other thing was GCNs. I didn't know if we wanted to talk about that.
Yeah, please.
Okay.
Yeah. If you want to talk about GCNs, yeah, maybe should identify or qualify what that means to people that maybe haven't heard of them.
Yeah, graph convoluted neural nets. I'm assuming everyone knows what typical neural nets are. This is using the graph structure as a feature itself. So typically you're deriving a feature set and then using that to create that model. In this case, you would take the structure of your data and the relationship between your data to then derive a feature in itself. So the structure of your data, it becomes the feature that you use to then train the model. When you use that, you can actually strip away all of your features. So let's say we do, well, actually, I'll give a plug to Parker Erickson.
I was going to ask, yeah, you brought that up, that he released something.
Yeah, he just created a blog. So it's taking Crunchbase data and he's trying to predict the IPOs. So he's taking the structure of the current IPOs and then trying to find companies. He knows that they're going to IPO, but he's going to see if he can predict that they're going to IPO. So the cool thing about the GCNs is that even with the features extracted and like stripped, let's say you have no features except the structure of the data, you're still able to get this really phenomenal score. And so he was, predicting high 80s, maybe I think even low 90s percentage of, maybe not in the IPO one, but definitely other use cases that he's done with GCNs. He was able to predict a very high accuracy with even no actual features except the structure of the data. So I think that's really interesting. That's something that's sort of a new thing. There's been more papers since 2017, 2018, I think is when they started really coming out with those GCN papers. I'm sure we can put a plug in the description for some GCNs and Parker's blog.
Absolutely. Yeah. In fact, I'm looking forward to reaching out to Parker here and seeing if he wants to be on a future podcast as well. So how does that differ then from something like TensorFlow? Would you have any thoughts on that? I mean, the graph portion, does this get actually loaded into Tiger Graph, or is this something that sort of sits external to it and based on, the vertices and, the nodes or whatever that are part of the graph? that's what you're sort of looking at?
Essentially, running like those kind of algorithms is sort of a graphy thing. You can you can do it in the graph, right? You can actually rebalance all your connections. No, to fact, they're working on actually simulating. I don't think it's actually a better solution. It's so new. We haven't really figured out how to optimize it and like execute it in graph and specifically Tiger Graph. So what we are doing is it's taking the structure and executing it in a GraphX. And then, you should probably ask Parker because he does all the, I'm trying to like, really pick my brain to remember exactly what he did on everything.
Sure.
But yeah, I would say optimize. Like, yes, you can definitely like replicate it in the graph. Is it the best solution? No. Could it be the best solution in the next year? Maybe. I don't know. It could be. It's totally feasible. It's just at this particular point, it's so new that we haven't deeply explored it. So it's best probably to do that outside of the actual graph.
Obviously, you've been working in graphs for years. Is this a case where, yeah, I guess maybe it's just the maturity as these databases are maturing, we're starting to realize, and probably with any technology, right? It's like, oh, we maybe have a narrow fit for it, and once it starts getting implemented and used over time, we're like, holy cow, it can be used for all these other things, and we can start adding in new pieces on top of it. Is this maybe the next evolution for graph, or I guess even where do you see graph going in the future? Maybe that's a better question.
Yeah. What's interesting is graphs everywhere already, and people don't understand it. Yeah, everything you do is probably touching a graph at some point. So back in 2012, and Dan probably talked about it, Google came out with their paper on knowledge graphs. And so if you're using Google search, you're using graph. If you're using Amazon, you're using graph. If you're using Facebook, you're using graph. If you're using LinkedIn, you're using graph. Pretty much everything you touch has graph in it at some point. So where do I see it going? I definitely see the machine learning space going to be a hot topic just because there's so many things coming out with that structured data and using that as a feature to derive new insights. The integrations tightly, deeply integrated with the system. I see that definitely in the foreseeable future. Generalized artificial intelligence is something I think people are starting to talk about. And so if you think about graph is a replication of sort of your brain, the way that your synapses are. So I think definitely in the future, it could be a backbone system to an augmented brain. I think that's definitely possible. I hope it's on Tiger Graph for sure. Because
Sure.
I'm really into that Jarvis stuff. Anything like augmented reality, I follow Elon Musk and his Neuralink project, and according to him, we'll be able to fully access our brains in 10 years, and manipulate our access to data. And he's got an interesting perspective on our ability to disseminate and to interact with data streams. So even us conversing here is a really lossy system. So this isn't my articulated thought. I read this in a really well thought out blog article. If I can find it, I'll repost it here because it's a really long read, but it's really nice. And to why he is looking at doing the Neuralink project to compete with AI, because he thinks that AI is going to take over the world and we need to compete with it, right? Otherwise we're going to be like a tree, he says. No AI wants to go talk to a tree, just as a human might not want to talk to a tree.
Right.
It's not really interesting. So Neuralink, his thought process on this is, imagine you and I are friends. Of course we are. So imagine I go to a movie theater, and I'm at this movie theater and all these images are coming up and I'm just like, oh my God, this is so awesome. I love this. And then it goes really like scary and dark and all these, and then it goes, happy again. And then all of these things I'm feeling and I'm absorbing. And then I go talk to you, Justin. And I say, Justin, this is the best, scariest movie I've ever seen. Well, what is going on in my head is I'm ingesting all this information, a huge bandwidth of data ingestion. And then I'm compressing this data in my mind. And then my compression algorithm has to go through a mechanism called speech. And so then I have to like compress it into a word, and then I'm compressing my thoughts into a word.
Yeah.
And then you take that word and goes in your ears and then comes into your brain, and then you're uncompressing what scary means. And your definition of scary could be totally different than my definition of scary. And so there's a huge loss in data from human to human. And so his whole thing is, how can we have that high speed bandwidth between mind to mind and mind to computer? And for right now, we're sort of already in a world of augmentation where we're using our phones to augment our intelligence, but we're interacting at a rate of 2 thumbs. In my case, 1 thumb. For those of you that don't know, I did lose mobility in one of my arms, and so that's one of the main reasons I'm a technology enthusiast and looking at brain-computer interfaces, understanding how technologies works. Really cool research being done in University of Minnesota, where they're actually taking brain signals and then converting that into. They're actually having machine learning on the brain signals, and then what they're doing is converting that into an output of the hand, and so you can actually move the hand with your mind. So they actually implant a chip in your wrist, but they have to retrain the models every so often because your mind's always reconnecting different circuits. So you have to retrain the model. Yeah,
Really? Oh, that's fascinating. That's going on here at the U, huh?
yeah. At least I went to a talk there, and pretty confident it is at the University of Minnesota, unless it was just some guest speaker that came in. But it sounded like it was from there.
Sure. That whole story about a person having experience and then sort of pushing data over, through voice to another person and their sort of interpretation of it. It reminded me, I'm reading a book called 21 Lessons for the 21st Century, and it's
Mm.
really interesting. And I think I'll bring it back and talk a little bit about what the author was sort of speaking about. But one of the things that he talks about in that book is, well, you talk about becoming a tree. So he talks a lot about just becoming irrelevant, right? And uses the story of a horse, right?
Yeah.
So way back in medieval times, horses were great for travel. At some point, they were actually good for farming.
Mm.
Now we're at a point where horses don't do anything,
Yep.
right? And so the whole theory about this is pretty soon humans will become irrelevant, right? That in the future time, everything's going to be automated. It's all going to be controlled by AI.
Mm.
And why do we even exist at sort of any point? But the other thing and I'll circle back and ask you a question specifically on that because I want to get your thoughts on that. But he also talks a lot about just like we understand hormones, we understand human physiology, and what are the hormones that are secreted that make people feel certain ways. Yours is different than mine, obviously,
Mm.
but if we know that based on a certain song being played, I will have a certain feeling, a certain emotion. And so, how could we then tailor songs to make us feel happy, to make us
Mm.
feel sad, put us in a different state of mind, to be more thoughtful, to be more productive, what have you. And an AI could continually sort of train that over time and kind of put a person in a certain mood that they may have fallen into, but the science behind it and the artificial intelligence could make us be that way. So what I was thinking about was yes, you had this experience at the movie theater and your body chemistry changed. Like how could you use, and again, there needs to be some sort of mechanism, some sort of mode of transportation to get it over to the other human. But it's like, yeah, is there some sort of way that we can use a different, and maybe that's what Elon Musk was talking about,
Mhm.
is like, right now you're right, it is very lossy, but is it literally just like a electrical current that would go from human to human, for example? And why, by the way, we got the internet, right? So I could do this to people anywhere around the world,
Yeah.
and all of a sudden that person can actually really experience that exact same feeling that you had at the movie theater, mainly knowing obviously what chemical composition changed on your side, and then putting it into what would make the same chemical composition change on my side.
Yeah.
Does that make sense at all? And is that sort of in the same realm of what he was talking about?
Yeah, I think that's totally on the same thing. And what you're able to do, from my understanding, with the Neuralink project, is fire off those same signals, so the same feelings. But the thing is that he said it's like your hand. Your hand won't move unless you
Mm-hmm.
will it to move. So he expresses that it's also going to be the same for your augmented intelligence. But the scary part is, I as we fuse, I mean, everything's probably scary. I'm sure the internet was scary, and light was scary, and everything that precedes it was scary. The train was scary. Riding an elevator that's automatic was scary
Yep.
because you had the manual guy. But now, if I wouldn't trust a guy that was doing an elevator with the little thing, like maybe he's having a bad day.
Right.
So and then we'll be looking at cars. Oh, you drive a car? What? It's the same looking at the guy with the elevator. Like, I wouldn't trust this guy with the car.
Right.
Like,
Right.
so that does scare me, though, with the having direct link to the internet with your brain. But I do feel, you're going to be significantly handicapped with the exponential abilities that you would gain from such a thing.
Yeah. That's one of the things that happens with a lot of these new technologies is because the person next door is using it.
Yeah.
In order to keep up, I kind of have to use it.
Yeah, it's like saying you don't want to use the internet,
Right.
because it's scary. But and of course, you lose your privacy and things like that because you're on the internet. But there's so much gain from being on the internet. So what do you do? Do you use the internet, or do you not use the internet?
I'm curious to see your thoughts as sort of the founder of Futurist Academy, but
Hmm.
what happens in the future of work. So again, we have kids that are learning this stuff, and as AI becomes more prevalent, I talked about the horse basically becoming irrelevant. What do you think happens, and what do our careers look like, I guess, for people that are 5, 10, 15 years out?
I haven't read it deeply into all of the predicted outcomes, but I do believe that we might get to a state where it's purely ran on just enjoying life because we're humans and we want to have technology serve us. So we become lazier and lazier and can do things that we enjoy. I think that trend's going to stay. Not to say like all humans are lazy, but they can focus on things that they're really interested in, and not worry about like the minute things, mowing the grass, and unless they want to enjoy mowing the grass, then they can mow the grass. But everybody, you have a long day, and then you're coming back, and you're like, oh, I really want to mow that grass. So I think technology is going to lead us to the point where we can focus on things that we want to focus on more and have a better quality of life. We do need to fix some things with how we are working with technology and living in this world. I think there definitely needs to address the global warming, probably I guess sticky topic, but I think there's a lot of things that we could do for that. There's a
Absolutely.
lot of things that now, because we're in this world of COVID, my hope is that we understand what's really important. We focus on that. We start to apply our minds to solving real world problems so we can get to a point where we can thoroughly enjoy life, and everybody has that same quality of life that they can thoroughly enjoy. So when we all have the ability to have robotic hospitals, or where something like could do total surgery for you. I'm not a surgeon or a expert in that particular healthcare space, but my understanding is there's less and less people being doctors and surgeons and things like that. So if we need to address that gap, technology is there. How do we get the robots to be able to do surgeries? And I already know they are doing surgeries, but how do we have like a fully automated surgery room and things like that? Definitely going to have some kind of applied AI and technology that's going to be in these kind of spaces.
Do you think an AI could do your job today?
Connecting with people and teaching people, I think that's a very humanistic thing that you need, because my job really is understanding people, understanding what drives them, what makes them excited. And my journey so far, and I don't know where it's going to go. It is a journey, and I try to live in the now and focus on providing this value to the world. And yeah, I think my particular job is really around that human connection. So I don't know if a robot could really simulate the human connection and understanding humans. Maybe they are getting better at that. I've at least mimicking humans in the human interaction. But truly understanding humans, yeah, I guess you could take data and try to understand humans. But they did that with Twitter and made a Twitter bot that tried to understand humans, and then it went on a rampage.
It did. Yeah, you're right. You're right. It completely went off the rails. So yeah, there's still ways off on some of that.
Not to say that maybe when the generalized intelligence comes here that they'll be like a really caring robot that's human like.
What's interesting is some of the creative fields have always been like, oh, AI could never touch that. AI could never write a symphony. Well, it did,
Mm,
right? AI could never paint a piece of artwork. Well, it did. And then the thing that I've kind of been holding on to, at least until recently, is AI could never write a software algorithm or write a program. Basically, right? We humans on keyboards typing. It's
yeah,
like no. So I think the whole future of software engineering, since is where my background
yeah.
is definitely going to change, and it's not going to be fingers on keyboards typing stuff out. It's really going to be more on the creative side. I mean, as I work and more in like TensorFlow and stuff like that, it's really dialing the knobs
Mm,
on the outside to try and figure out the best thing, and letting the computer do what it's best at, and optimizing algorithms. I think about just like SQL database writes. Pretty soon you're just going to speak, find me this stuff, and it'll go out, and
oh yeah, no, you're just gonna think it.
you're just
You're
going
just
to
gonna
think it.
think
Yeah.
it. Yeah, it's like okay, there's a calculator there. Do I want to do it by hand, or do I just want to punch some numbers in? Oh, yeah, you're gonna the calculator. No,
Totally.
that reminds me of doing work. So one of the students was saying that, oh man, I got to do this history paper. I was like, well, why don't you use deepfake to, see if it's. I said, literally, you can have the deepfake write your paper and submit it and see if they'd actually know it. And like, you can't get mad at a student if he articulated and executed a deepfake paper and it was so realistic that they actually got accepted. And I mean, I would give the kid some credit for that.
Right. actually digging in, figuring out how to stand it up and get it working. Yeah. Or even thinking outside the box. Yeah. I mean, how can I optimize this as best as possible? Have a computer do it.
Yeah. Yep. Yeah. So it's definitely interesting.
So yeah, I want to give you a little bit of time to plug your stuff here at the end. I have like just a couple more questions. Are there any classes that you advise people taking as you've done over time? Any books, conferences, stuff that you find interesting, I guess, and then I guess I'll let you talk about how people can reach out and connect with you as well. But yeah, I'm just kind of curious if there's things that are top of mind. Someone's getting into this field, graph or non-graph, emerging technologies. Well, what are some things that sort of come to mind that you think are interesting?
Yeah, I would definitely try to figure out what are the major influencers, try to find the people that interest you that are in the space that you would like to follow. Also, creating a network of brilliant AI mentors is really important. So I'm sure anybody from this group would definitely help anybody that's interested in AI. No questions asked. I would say 99% of humans, if you ask for help, they'll say yes. There's very few humans that I know. Actually, I don't know any. So
Right. 100%.
I mean, I try to keep people positive. So, yeah, so it's a pretty good chance if you ask somebody literally for help, and it's not like you want them to solve your thing, but you're just generally curious about something or just want some mentorship. Yeah, they'll help. Like, so I would say definitely surround yourself with mentors, surround yourself with like-minded people, find people to learn with, find people to grow with, to be excited. I just built this and share it, and they get excited and they like sharing their thing. I would say mentorship, find those communities, and then just explore things that are interesting to you. I do find value in curriculum, like going deep in courses, but I do find a lot more value in just sort of exploring that first like tier of all these different things. And then when you get to a point where you're like, oh shoot, I can't understand it, and then you're trying to go deeper a little bit, then it's really important that you go and find that the right course to go deeper. I would advise not to learn about the whole ocean.
Mm-hmm.
You'd be riding your boat on the top of the ocean, and then once you find like an interesting shipwreck or whatever, you just dive deep, right? So
Mm-hmm.
so yeah, you don't need to learn the ocean, just to sort of explore, play, learn, and then once you find something passionate about that's really intriguing, really interesting to you, try to go deeper, find the book, the curriculum, find the mentors.
That's great advice. Great advice, John. Yeah, totally. So how can people find you? Obviously, your LinkedIn, Twitter, what have you, and I'll include all this stuff in the liner notes too as well. But yeah, what's the best way for people to reach out to you?
I would say LinkedIn. LinkedIn is probably the number one place that I am in 24/7. And so if they want to connect with me, just look at the link on this. I'm sure the link will be there.
Mm-hmm.
Otherwise, search my name, John Herke, JONHERKE, and then send me a request, shoot your name, and then say a little intro to who you are, and then I'll accept your connect. So, and then we can talk and we can riff off ideas.
Great, awesome. Well, thank you, John. I appreciate all the time. It's been a great conversation, and wish you all the best. And I know you'll continue to press us and do some amazing things here in the community, not only around Graph, but helping kids get more into this with the Futurist Academy and everything going forward. So
yeah,
thanks again. I appreciate it.
Thank you, Justin.
All right, take care.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.